Now this one we saw a little bit ago. It was a while ago. We actually kind of talked about this closer to where we talked about transformations. This is called vertex form. And the first time we did vertex form, it was like the first time we had used completing the square. And we weren't, as good at that yet. But now we've done complete the square many times, and we're a little bit more familiar with that technique. So I think when we go back and practice this again, this will be a little bit easier for you guys to put it in vertex form. But I know that was kind of tricky for you, for some of you at the beginning. Now, vertex form is kind of interesting. You can definitely see the vertex here, right? If you have a minus h and then a k, the vertex is hk. So you take the opposite of this guy, and then you take this guy. You don't have to switch this one. When we have the minus k down here in focal form, you do take the opposite of it, but when it's just by itself floating around, you just take that k. So we'll see what that looks like in just a second. The other thing I wanted to show you is this is basically a transformation on x squared. A is still the vertical stretch factor, just like it was in the other two, right? A and A, same A. H and K now are going to give you the vertex. So in these first two forms, we don't really have a quick way of seeing the vertex. We can get the vertex from this form by doing our opposite b over 2a kind of thing. But we see it a little bit more clearly or a little bit more easily when we're in vertex form, which is why it's called vertex form, right? So H and K. And then the A, of course, is the vertical stretch factor. A lot of times, like as I did some research here, I'll see a lot of people call this vertex form transformational form or transform form. And I think that's pretty obvious why. It's because you can see all the transformations. You can see the vertical stretch, you can see the horizontal shift, and you can see the vertical shift as well. So in this form, you basically can say, oh, this is just a transformed version of x squared. So sometimes it's called transformational form. But there is another transformational form out there that people use that's actually a little bit more similar to the standard form here. So there's yet another form that we're not going to go into. It's similar to standard form here. There's just some things that are moved around on different sides. We're not going to get too much into that, but I just wanted to let you know that there's some debate on what we call transformational form as well. So sometimes people will call this transformational form, but most of the time I've seen it, people just call it vertex form. You can easily see the transformations on it, however, which is kind of nice. The way we get into this form is by using complete the square, which again, we practiced a few weeks ago, like before spring break. We're going to practice that again tomorrow. We're going to go back and look at all these forms in a little bit more detail. Okay, let's take a look at this one and jump into Desmos. So a times x minus h squared plus k. So let's get rid of these guys. All right, so we got y equals a, and then we have x minus h, and then we have our squared, and then we have plus k. Okay, so let's make a slider for each of those. Okay, and again, they're just going to default to 1, 1, 1, 1. So right now, this is just x minus 1 squared plus 1. Okay, and notice here's my vertex, right? Right here at 1, 1. If I were to write this out with these values for a, h, and k, what it would look like is 1 times x minus 1 squared plus 1. So we don't really need this one. That's the vertical stretch factor. We're not really stretching it at all. But what I want you to notice is that the vertex is at positive 1, 1, right? Positive 1, positive 1, 1, and 1. So if we have it in this form and we're taking the vertex, we need to take the opposite of this guy and then just this guy back like normal. We don't change that at all. Let's change the parameters a little bit, or change the values here and see our new vertex. So let's go to 2, 3, okay? We'll get rid of this because we don't need that anymore. So now, again, the vertex is at 2, 3. It's at 2, 3. But if we wanted to actually, write what this equation would look like, we'd have the 1 for the stretch factor, which we really don't need, x minus 2 squared, and then we have a plus 3 on the outside. So the vertex is at 2, 3, right? 2, 3. But the equation is going to be x minus 2 squared plus 3. That's how you get it at 2, 3. So again, if you're looking at the vertex form, to find your vertex, you have to take the opposite of this and then this guy. That's kind of like that horizontal shift we talked about a long time ago. When the number is inside the parentheses with x, it shifts opposite of what we expect it to, right? We expect this to go left, but it actually goes right. So that's kind of what's going on there. Now the A is just still our vertical stretch factor. So watch, the vertex won't change, but I'm going to stretch it. Okay, so the new one is the red one. The original is the black one. We can go back to 1 here. We can also turn it negative, right? And of course, that's going to flip it down. So anyway, that's kind of what's happening with that one. All right, let's jump back and talk about the last form here. And after this, you will take a lesson like video quiz. We'll just kind of, I just basically in this quiz want you to be able to pull the pieces out of the different forms to know the different forms. And then the next assignment, which will come tomorrow, depending on when you're watching this. If you're watching this on Monday, it'll come tomorrow. We'll actually do a little bit more algebra, converting between forms and things like that, and making some graphs. But first, we just want to identify, the pieces and what each of those forms looks like and why we have different forms. SM2, we really want to look closely at parabolas. This is the semester where we do that in math, and we just want to break it down in every which way, so we really understand them.